try to calculate this determinant. I give you guys 1 or 2 minutes. All right, this one, okay? Oh, another thing is I already assigned the homework for you guys. I just don't send you guys the email yet, okay? I already assigned the homework 4. Did you get it or not? What's your answer? 68. Let me check. No, you make a mistake. 0, 2, 1, 3, negative 1, 2, 4, negative 4, 1. Double check it. I'll give you guys another 1 minute. It's 2. It's not 68. Mm-hmm. Okay, so now I'm gonna write down the answer for you guys. So follow the steps we learned from the last class, right? So the first step, we write down all the positive, negative, positive, negative, positive, positive, negative. This is negative, positive. Alternate the sign, right? So if we expand the matrix A following the first row, okay, if we follow the first row, what are we going to get? And the first element is 0, and then cross out the first row, first column, that is 2, -4, 1, right? Because the first element is positive. And the second element plus 2, and this is -1 because the sign is -1. So cross out first row, second column, we're gonna get 3, 2, 4, 1, right? And the last column is 1, right? And it's a positive, okay? And cross out the first row, the last column, 3, -1, 4, -4, right? Very good. Now we're gonna, the first guy is 0, 0 times everything is 0. We don't need to care. The second one gonna be cross product. And the third one gonna be 3, -4. So here is -12 plus 4, right? And again, it's -2 times -5, 10. Equals 2, okay? Now I'm gonna give you guys another example. Similar, you can do a 4 by 4 matrix, for example. If I give you 1, -2, 3, 0, calculate the determinant of this guy. For the 4 by 4 is very similar to 3 by 3. What you're gonna do when you do expanding, the first thing you're gonna find the sign, right? So alternate the sign. Right? And then you're gonna do the expansion. What are you gonna do? That's a tricky one. The third column has the most zeros. You like to expand the matrix with the column having the most zeros. Okay, most zeros. Try it. Very similar to 3 by 3. Try this one.
the very first column? And what do you do with the third column?
Do the expansion.
I don't know if that could use.
Oh, you forget. Oh, you didn't come to my class last time. Okay. You should have watched the video before you come to this class. I have all the recording videos online.
I'll watch it.
You know it, right? Yeah. Did you get it or not? What's your answer?
I'm doing good.
No, that's wrong. Okay, let me try it on board. We do the expansion according to the last, the third row, or the third column. Okay, sorry. So we have what? It's a positive, right? Positive. So it's 3. And times cross out the first row, the third column. We're gonna have -1, 1, 2, 0, 2, 3, 3, 4, -2, right? And for the second element is 0. And be careful, here's a negative sign, times negative. And of course, you can cross out the second row and the third column, right? You're gonna get what? 1, -2, 0, 0, 2, 3, 3, 4, -2, right? And for the third element is a positive. We cross out the third row of the third column. So yes, 1, -2, 0, 0, 2, 3, 3, 4, -2. Okay, and for the last one is 0. Here's a negative. And we cross out the last row and the third column. We're gonna have okay, since the last 3 all times 0, everything times 0 gonna equals 0, right? So the only term that left is what? Is this guy. Right? This term is 0, this term is 0, this term is 0. Right? So now, how to calculate this guy? We're gonna do the expansion again, right? Expansion again. So we can follow the, for example, here we have a 0 in the second row. Of course, we can do the expansion. So we can follow the second row, right? So let's take a look. Three and 0, cross out the second row, the first column. 1, 2, 4, -2. That is a negative, right? 0 times -1. okay, because here is a negative, and plus 2 times the positive, okay. Cross out the second row, the second column. And the last one is 3 times negative 1. The second row is the last column. Okay, that's it. Right? Now we can simplify it. After you get this one, you should be very straightforward. So the first term is 0, right? 0 times everything is 0. The second term is negative 1 times negative 2, subtract 3 times 2. Third one is negative 1 times 4 minus 3 times 1. Right? And 3, that is 2 minus 6 minus 3 minus 4 minus 3. So here is 3, negative 4, negative 8, or negative, right? And this guy gonna give you 39. Okay, 39. Now I'm gonna give you guys another one that you guys try it. For example, okay, now try this one for me.
Say negative 12.
Negative 12. Let me check. Yes, you are right. You make it. Even you don't come to my class. Good job. Good job. Okay, let me try to onboard. So for this guy, we want to try the first row because here, right? Positive, negative, positive, negative. So first row has the most zeros. Okay. So 2 cross out the first row, second column. Of course, you can write down the 0 here, right? 0 times -1, blah, 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 and we're going to get 4, 0, 0, 5, 1, 0, 1, 3, 3. However, you already noticed that everything times 0 going to give you a 0, right? So it's meaningless to write down the left terms because you know there should be zeros, okay? Well, that's the first step, okay? So I just add 3 zeros, add 3 zeros, okay? Because here is 0, 0, 0. 0 times everything gonna give you the 0. So only thing we care about the first term. Of course, for the first term, we're still gonna follow the first row because the first row has 2 zeros. The same things times -2. First row cross out the first row, the first column. We're gonna get a 1, 0, 3, 3. Right? And then that is -12. Okay. That's it. So that's the determinant. Now today we're gonna go to the triangular matrices. Okay, triangular matrices. Let's take a look. 2 triangular matrices. A11, A12, A13, A1N, 0, A22, A23, A2N, 0, 0, 0, ANN. AN1, AN2, or ANN. Okay, so the first triangular matrix we call the up triangular. Up triangular matrix. The second one we called lower triangular matrix. For the upper triangular matrix, we use U, and as you can see, below the diagonal, they are all zeros. So we call up triangular matrix. For the second one, we can see above the diagonal element, all the entries are zeros, okay? So we call this guy is lower triangular matrix, okay? So that's the definition. Now, for the lower triangular or up triangular matrix, we have following properties for the determinant. Theorem 3.2. Determinant of a triangular matrix. Determinant A is the multiplication of all the diagonal elements. Okay, that's the most important properties for the triangular matrix. If we wanted to calculate the determinant of triangular matrices, we just let the diagonal elements times together. That's it. Very, very straightforward. Now let's take a look at the example. I want you guys try use the property to calculate this matrix. Try it by yourself. Okay, just try it. Use such a property. Okay, very straightforward. Just let the diagonal elements times together, right? 2 times -1 times 3 equals -6. That's it. And from the previous example, I gave you this matrix, right? A. Did you see it? That is what? Lower triangular matrix, right? It's very clearly because we can see above the diagonal entries, they are all zeros. So that is lower triangular matrix. So for this guy, we just let the diagonal entries times together. You're gonna get negative 12. The same thing as you follow the extension. Did you see it? All right, very straightforward. Now, let's continue. Property of determinants. if A and B are square matrices of order n, then determinant okay. So the property is if A and B are square matrices, determinant of A, B is a matrix equals determinant A times determinant B. Now, I'm gonna let you guys try one example. A equals 1, -2, 2, 0, 3, 2, 1, 0, 1. B, that is 2, 0, 1, 0, -1, -2, 3, -1, -2. Okay, I want you guys to calculate to find the determinant of A, determinant of B, determinant of AB. Try this one for me. I give you guys 3 or 4 minutes. Try this week, okay? I think in this class, one of the important things you're gonna learn is when is the determinant, how to find the determinant of a matrix, okay? Of course, previously we learned how to do the inverse of the matrix. Today we're gonna learn, recently we're gonna learn how to calculate the determinant, okay? So we already learned 2 important things in this class. I want you guys master the way to calculate the determinant. What is better for the determinant of A? Negative 7 or 7. No. Negative. How about the B? 3. 11. This one. 11. So I will write down the answer on board. You guys need to calculate it by yourself. Okay. So determinant of A should be negative 7, and determinant of B should be 11. And for the AB, you can calculate the AB. A times B equals the matrix 8, 4, 1, 6, negative 1, negative 10, 5, 1, negative 1. Okay, and then you calculate the determinant of this guy, you're going to get negative 77. Okay, so we can see the determinant of AB, negative 77, equals what? Negative A, determinant of A times determinant of B. Right? That's exactly the same thing. So next time, if I want you guys calculate this guy, you can calculate the determinant of A and determinant of B. Just add these two times together, you're gonna get the determinant of AB. Okay. Now let's take a look at the theorem 3.6. If A is a square matrix of order n, and C is a scalar, then the determinant of CA, that determinant CA equals C to the power n, determinant of A. Okay, now let's take a look at an example for this guy. So if we have scalar times A, that the determinant, if we remove the C from the determinant, gonna be C to the power n. Okay, it's not C. So for example, B equals 10, negative 20, 40, 30, 0, 50, negative 20, negative 30, 10. Okay. As we can see, in each element, here we have 10 times 1, 10 times negative 2, 10 times 4, 10 times 3, 10 times 0, 10 times 5, 10 times negative 2, 10 times negative 3, 10 times 1, right? It's very clear. We know that is a scalar C that equals 10, right? 10. So if we want to remove the 10 outside, you can just remove, as we did before. That's the 10, we remove this 10 outside of the matrix. We can do such a things. That is a scalar multiplication, right, for the matrix. Okay, very good. Now, I want to calculate the determinant of B. based on definition, I calculate this guy. I calculated this guy. As we can see, the formula tells us if it's C times this matrix, if you remove the C out of the determinant, you're gonna be 10 to the power n. Here is a 3 by 3. Okay, and then times this matrix, this determinant. Okay, 10 times this determinant, and you can calculate this determinant gonna be 5. You're gonna get 5,000. Okay, 5,000. That's another property of the determinant. So let's take a look at another theorem. Theorem 3.7. Determinant of an invertible matrix. A square matrix A is invertible, non-singular. Okay, if only if determinant of A, example 3. Determinant determinate whether the matrix is an inverse. The first guy is okay. So from the theorem 3.7, we can see if A is invertible, if A is an inverse matrix, that means the determinant doesn't equal 0. Okay, if equal 0, that means it's non-invertible. Now I gave you guys an example. For example here. So to check whether this guy is invertible or not, we just needed to calculate the determinant of this guy. Okay. We just need to calculate this guy. Try it by yourself. Try it by yourself. Okay. Calculate the determinant for me. You get the determinant. is 0. Good job. Sure. So that is non-invertible or singular. Okay, so we can do it on board. Positive, negative, and if we follow the first column, right? So we have 0, -2, 1, 2, -1, 3, 3 times -1, because here's a 3, right? The sign is -1. Column, second row, first column, 2, -1, 2, -1. And the last row, remove the last row, first column. That is 3, 2, -1, -2, 1. And basically here the first term is 0, -3, 2 times -1, 2 times -1, 3, 2 times 1 minus -2 times -1. Okay, and this guy will be 2, 0. This is 0, this is 0. You're gonna get 0. Okay, so based on the theorem, it's 3.7. If this guy equals 0, that means that A is singular or non-invertible. Okay, non-invertible. So let's take a look at this guy. I want you guys to try another one. This guy. 0, 2, -1, 3, -2, 1, 3, 2, 2, 1. Try this one. Okay. Okay. So for this guy, you're gonna get what? What's the result? -12. Okay, -12. That is -12. I will not write down the answer. You can do it by yourself. Okay. And this guy doesn't equal 0. That means A is invertible. That's it. Okay, based on theorem 3.7. Now let's take a look. Another theorem. Theorem 3.8. What is determinant A inverse that equals 1 over determinant A. Okay, that's very important properties for the inverse, because if you want to calculate the inverse of A or A inverse, the first step you're gonna do the inverse, right? Then you're gonna calculate the determinant. From this theorem tells you if we wanted to calculate the A inverse, we just needed to calculate the determinant of A, then let 1 divided by determinant A. That's it. We don't need to calculate the A inverse. Otherwise, it will require a lot of calculation, right? A inverse, we're gonna use Gauss-Jordan elimination. We got A inverse. Then you calculate the determinant. There are more steps. So this year, I'm gonna simplify it, okay? Now, I want you guys to calculate, find the A inverse determinant for the matrix. A equals 1, 0, 3, 0, -1, 2, 2, 1, 0. Okay, and calculate this guy for me. Use this property. Okay, please use this property. Okay. You get it? What's the determinant of this guy? Huh? 1. Let me check. It should be 1. You shouldn't make a mistake. 0. How about you? 1 over 4. Let me check. 1 over 4. That's right. Okay. Good job. So you calculate the determinant of this guy. You're gonna get 4. So the inverse of this guy gonna be 1 over 4. Okay. That's it. That's it. I'm gonna wrap it up.